Hello, I've had a question about Unit 4, Lesson 3, and it is question number 8. So, we have the motion of a particle described by this particular equation. And the motion it ends up being a cubic here. So t is measured in meters, s is in seconds. So A part wants to know when the particle's at rest. So whenever I do questions like this, involving velocity and acceleration, I just go ahead and find the derivative for each one. So that's your displacement. Velocity would be 3t squared minus 30t. And your acceleration equation, oops, there's a bit of physics coming back at me there. Acceleration would be 6t minus 30. So there are my three equations. Now I'm going to go ahead and answer A. So when is a particle at rest? So at rest, that occurs when v is 0. Your velocity is 0. So therefore, 0 equals 3t squared minus 30t. Common factor out of 3t, and that would leave me with t minus 10. So therefore, the solution would be t equals 0 and 10. So at 0 and 10 seconds, the particle is at rest. Is at rest. So there's A. B, when is the particle moving in the positive direction? So all I'm going to do here, I'm just going to give myself a quick sketch for B, because that answers my question. I'm going to graph my velocity equation against time, because velocity tells me when it's moving forward and backward. So going back to this equation right here, this is a parabola. It's opening up. And I know my x-intercepts are at 0 and 10. So the parabola is going to look like this. So whenever we have positive, we're moving forward. Whenever we have negative y values, we're going backwards. So therefore, moving back between 0 and 10, moving forward when t is greater than 10. So we can just do that from the sketch. C part, do that over here. Draw a diagram to illustrate the motion of the particle. So, give myself rough axes here. So we're using displacement. I know that velocity is 0 at 0 and 10 seconds. So that tells me where we have max and min. So our graph will look like so when we look at the equation, I know that the y-intercept is going to be at 63. So again, this is going to be a rough graph. I know that the slope of the tangent, so if I look at my velocity equation, slope of the tangent is 0 and 10. So I know I have an inflection point in the middle. So the graph is going to look something like this. So this is one of the humps from a cubic. It's going to come down and move forward again. And there's a 10 seconds where that velocity will be a 0. So that gives you the motion. The distance traveled in the first 10 seconds. So distance, we got to look at it in terms of, if we use that equation that's given, the S equation, that's displacement. So we really want distance traveled. So our distance will equal our final destination. So it will be the value at D10, minus d of 0, and I just take the absolute value of that. If I had to go beyond 10 seconds, so let's say I want to know at 15 seconds, I would have to add on this segment, and it would look like distance at 15 seconds minus the distance at 10 seconds, and that would get added to that value right there. So every time you're moving forward and backward, you have to add or find that particular value. So I know in this case, from my equation, if it was 63, And we need to plug it in for d of 10. Need to get a calculator. So according to my calculator, it's negative 437 for my, so my sketch is obviously not even close because that's got to be way down lower. So if we take 63 away from that, take the absolute value, it means that the particle traveled 500, I believe it's in meters, 500 meters. Okay, so I'm not really worried. It's more the shape of the graph that you're worried about. If your sketch is that far off like mine, it's not a big deal. Hopefully that answers your questions. If you have any others, let me know and I'll see if I can help you out.